Hi there. This is a video about inequalities, and there are always a few inequality questions on every test. So let us begin. We're going to start with test 1, section 4. We're going to do numbers 11 and 18. So 11 reads, which of the following numbers is not a solution of the inequality 3x minus 5 is greater than or equal to 4x minus 3. Now, there's a couple of things before we even get into doing the problem. There's this big not there. So if on a test you see something that is capitalized or underlined or italicized or in some other way set apart, your job is to circle it, and circle it, because you will pay more attention to your own handwriting, your own markings on the test, than you will to what they have marked up. So this is an important point, not just for this kind of question, and not even just for math, but for the entire exam. Okay, now the second thing I want to go over is for the people who get confused between the greater than and the less than signs. And I've had all kinds of students have this issue, whether they're taking calculus or otherwise. All right, so let's say we have 5 is greater than 3, 1 is less than 4. Okay, so here's how you think about it. We read from left to right. So when we're reading, we read 5 is, and here is the bigger part of the inequality sign. So 5 is bigger than or greater than 3. Here, from left to right, 1 is, here's the itty bitty part of the inequality sign. So it's the less than. 1 is less than 4. All right, take that to heart. I'm moving on. We are going to treat the inequality just like it was a regular equation with an equal sign. We're going to get all the x's over to one side, so I'm subtracting out the 3. And we get negative 5. Remember to retain that sign. Is greater than or equal to x minus 3. We add the x over to get, we add the 3 over to get the x alone. And we get negative 2 is greater than or equal to x. I always turn it around so that the x, or whatever variable it is first. That means the small side of the inequality has to be pointing toward the x. So we're going to turn that sign around to make sure we have the math right. Now, we look at the answer choices. And if we remember, they're asking for an answer that is not a solution. So let's see, A says negative 1. And we ask ourselves, is negative 1 less than or equal to negative 2? And the answer, of course, is, well, no, it's not. Right? If we look at a number line, and this is 0, and let's say we have 1 here and negative 1 here, negative 2 is further down to the left. So negative 1 is actually greater than negative 2. So A turns out to be our answer. All right, now let's flip over to number 18. And I think I'll do this in a different color to distinguish. Right away, we've got two inequalities up at the top. We've got y is less than negative x plus a, and y is greater than x plus b. And we read, in the xy plane, if 0, 0 is a solution to the system of inequalities above, which of the following relationships between a and b must be true? Well, they're telling us that 0, 0 is a solution, which means we can plug in our x and y values in for x's and y's. Well, everything is 0 here. We've got x's and y's are all 0. So if we translate these equations now, or these inequalities, the first one is 0 is less than 0 plus a. Another way of saying that is we can just get rid of that 0, So 0 is less than A. And as I told you before, you always put the variable first, and then we switch around the sign so that large side of the inequality is facing the A, and we got A is greater than 0, or this is going to be a positive number. For the second equation, we've got 0 is greater than 0 plus B, and again, we can cross out the 0. It is not useful to us mathematically. And we're going to turn around that equation so the variable is first, and then the small side is facing the B, and we have B is less than 0, which means this side is negative. To answer the question, we need to know the relationship between A and B. Well, if A is positive and B is negative, it's clear that A is going to be bigger than B. And that, my friend, is letter A. A is the answer. Okay, so that covers that test. Now I'm going to clear the decks here, and we're going to move on. And the next question is going to be test 2, section 3, number 12. And again, we have two inequal, is that right? Sorry, little mix up here. I'm on the wrong test. Here we go. Okay, so we have a word problem. Now, the reason why we know it's inequalities is because when we look at the answers, we have inequality signs. So let's read this word problem, and we're going to read it like I would any word problem. In other words, not read the whole thing. Just take in one little bit of information and write it down. So I'll read the first sentence. On January 1st, 2000, there were 175,000 tons of trash in a landfill that had a capacity of 325,000. So I'm going to stop. And this is exactly what you should do on your test. 175,000 now. That's what we have right now. But there's a capacity of 325,000 total. So now I never have to look at that sentence again. Now I'm just looking at my own notes. Okay, we read on. Each year since then, the amount of trash in the landfill increased by 7,500 tons. All right, so now I stop and say plus 7,500 per year. If Y represents the time in years after January 1, 2000, which of the following inequalities describes the set of years where the landfill is at or above capacity? So I'm interested in that, at or above capacity. We know that the capacity is 325. So I'm going to write down 325,000. And it's at or above capacity. So we're going to have something like the amount of trash is going to be at or above, greater than or equal to 325,000. Now, I'm going to stop and I'm going to just take a look at the answer choices because you always want to do that. You don't want to have to do more work than is necessary. So when you do something, look at the answers and see, can I eliminate some answer choices? What we're looking for basically is yada, 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 greater than or equal to 325,000. And if we look through all of the answers, D is the only one that works. It's the only one that has that. So we can stop, pick D, and move on. This, my friend, is saving time. Okay, so take note of that. All right. Now, that's all I have for particular questions on these tests, but I still want to give you a couple of sample problems. So let's see. Let's do one that's 3p minus 2 is greater than or equal to 1. And let's say the question is asking for the least possible value of 3p plus 2. All right, so there are several ways to think about this problem. The standard way is just to solve for p just like it's an equation with an equal sign. We add the 2 on both sides, and we get 3p is greater than or equal to 3. and divide out the 3 to get the p alone. We get p is greater than 1. Then we plug the 1 in for p, and we get 3 times 1 is 3 plus 2, and that's 5, and 5 would be an answer. So that's great. Another way of thinking about it is you could have stopped right here where it said 3p is greater than or equal to 3. And you could have said, hey, well, they're asking me to solve for 3p plus 2. So if we just add 2 to either side, we get 3p plus 2 is greater than or equal to 5. So again, we get the same answer, slightly different way of looking at it. Here's a third way of looking at this. 3p minus 2 is greater than or equal to 1. That's the original problem. And we want 3p, I'll just write it here, 3p plus 2. Well, the difference if we from plus 2 to, from minus 2 to plus 2, and we can even look at this on a number line. So we have minus 2 and plus 2. We've got minus 1, 0, and 1. The difference is 1, 2, 3, 4. So if we add 4 to both sides, we get 3p plus 2 greater than or equal to 5. Again, same result, different way of thinking. And honestly, you can probably do this with most of the problems on the test. There are always numerous ways of looking at things depending on how your brain works. They're all right. They're all good. And if you like the first way the best, then that is fine. Then that's what works for you. Now, I do want to mention one other thing that's really important about inequalities, and that has to do with negative signs. So let's just take the same problem. It's greater than or equal to -1, let's say. And let's say -10, in fact. Okay, so we're going to solve for p. And again, we're going to do it the same way. We're going to add the 2 to both sides. And you get 3p is greater than or equal to -8. You know what? I'm just going to change this to a negative. Okay. Now, -3p. Now we're dividing by a negative, and here's the key. When you divide by a negative in an inequality, the inequality sign changes. So we end up with p is less than or equal to 8/3. Okay, so if you're dividing by a negative, you got to flip that inequality sign. Okay. I think that's all I want to say. You know what? I want to do one more. I just thought of another example. Okay, so let's say we've got, let's say 2x minus 1, and then we have 2x is greater than 5. Okay, this is going to be our last problem. And the question says solve for y. So we want to keep the y, right? Now, you could do this, again, a couple of ways. If you're lucky, I don't know how much luck that there is in that, but if you see this, you will see that this 2x is just like this 2x. And it says this 2x is greater than 5. So if you just substitute that 2x by the 5, you plug in 5 for that 2x, you will get, I'll just write it down here, y is greater than 5 minus 1, y is greater than 4. Now, you may be saying, well, wait a second. It doesn't say that 2x equals 5. It says it's greater than 5. So why are you just plugging in 5 for the 2x as if it was equal? Well, here's why. Because it says 2x is greater than 5, but here it says y is also greater than. And so you can, because the signs are the same, you can treat it as though it's equivalent because they're both saying, we know it's not equal to, we know it's greater than. So if you plug it in, it's still going to be greater than. Now, you may have seen it differently. You may have said, well, I'm going to plug x in for this x. Well, that's fine. You get 2x is greater than 5 and just divide out the 2. So you get x is greater than 5 halves. And then you would plug the 5 halves in for x. And let's go ahead and do that. You get y equals 2, we'll do 2 over 1, times 5 over 2, and all that minus 1. Well, these 2's would cancel out. So you'd end up with just the 5, and you get 5 minus 1, or 4. So either way, you get the same answer, different way of looking at it. Okay, my friend, that is all I have for you on inequality. Take care.